Hello everyone, welcome to Legacy IAS. This is our first video on time, speed and distance. Now, time, speed and distance. You already understand these terms. Time is time, speed, speed, distance is distance. Okay. One very basic formula is that you all know is speed is equals to distance upon time, or distance is equals to speed into time, or time is equals to distance upon speed. These are the three basic formulas, correct? Now, time, speed and distance. Now, another term that you might have seen a lot in questions is relative speed. Now, what is relative speed? The relative speed, let's say there are two cars. So, this is car 1 going in this direction. Now, this is car 2 going in this direction. Now, or yeah, going in this direction. Now, see this. This is a car going in this direction. This is a car going in this direction. Let's draw this also far. So this is a car going in this direction. Now you tell me, if these are the two cars, now they're both approaching each other. So whatever is the distance between this car, whatever is the distance between these two cars will be covered by what velocity? Let's say this is going at speed of v1 and this is going at speed of v2. Velocity, speed same here. So it is going at speed of v1, this is going at speed of v2. Now how much time will it take to cover this distance? Now you can see that both of them are moving towards each other. That is, both of these speeds, or the motion of this car is getting combined to cover this distance. That's why time is equals to, time will be what? Distance apart, time to meet. In how much time they will meet? So this will be distance apart upon divided by the relative speed. Now, relative speed in this case will be what? Because they both are working together to cover this distance. So, in this case, time will be equal to whatever is the distance d and the sum of their speeds, that is v1 plus v2. Now, in the other one, now they are moving in the same direction. Now, if d is the distance between them, now this car is going away or increasing this car is increasing the distance between them. Let's say this stops here, okay, this becomes stationary, then this d will keep on increasing because of, let's say this is because of the speed of first one. Now this will keep on increasing. Now if this stops right here, then can you see that this d will decrease with speed of the second vehicle, correct? With v2 speed it will keep on decreasing. So this is trying to decrease the distance. Here this is also trying to decrease the distance, this is also trying to decrease the distance. That's why they got added. Here this one is trying to decrease the distance, but this one is trying to increase the distance. That's why they will be subtracted, as you will see. So the time taken for them to meet will be equal to, again, distance apart upon the relative speed. Distance apart is what? D. Relative speed will be what? Difference of these two. That is v2 minus v1. Correct? Because this only is trying to reduce the distance or cover the distance. That is just increasing the distance. So I have subtracted this. Now, one more thing you can observe here, that if the velocity of the first one, if the velocity of or the speed of first one is greater than the second one, then what will happen? This will keep on going very fast, this is much slower. So this will leave, and the one that is behind will not be able to catch it ever. That is why the time of their meeting will become what? If you put it here, if v1 is bigger than v2, what is the time of meeting? You will get something in negative. That is, they will never meet, because time cannot be negative. So this also is getting satisfied by this. Understood? So if one thing you have to remember, in all of this relative speed concept is this. It's this. That is, time taken to meet will be equal to distance apart upon relative speed. That's it. Then let's get to questions. Okay, what it says? It says a bus is moving with a speed of 30 km per hour. A car is chasing it with a speed of 50 km per hour. Okay, so bus. This is bus. Bus is moving at 30 kilometers per hour. Now, car is chasing it at 50 kilometer per hour. Correct. Now, how many kilometers apart are they if it takes 15 minutes for the car to catch the bus? Formula is the same, that is time taken to meet or to catch whatever is equals to distance apart divided by relative speed. Now, as you can see, this is trying to increase the distance, this is trying to decrease the distance, correct? So relative speed will be negative when they are moving in same direction. When two objects are moving in same direction, relative speed comes out to be something like this in subtraction. When they are moving in opposite direction, relative speed is comes out to be something addition. So this is relative speeds. Now, distance apart is what? What is the distance between them? We don't know. This distance only we have to find. Let's say this is d upon. What is the relative speed? 50 and 30. Going in the same direction, 50 minus 30, that is 20 kilometer per hour. Now, next is this is equal to what? Time is given to you. Time is given to you as 15 minutes. But here the speed is in kilometer per hour. It is in kilometer per hour. Now, that 15 minutes you cannot put directly here as 15. You have to convert it into hour. That is 15 minutes means what? 50 by 15 by 60, or simply 1 by 4 hour. Anyway, you can write 15 by 60 hours. How many times this will go? This will go one time, this will go 4 times, then one time, this will go 5 times. What you got? You got d is equals to 5 kilometers. That's it. So the distance came out to be 5 kilometers. Okay, so that is the distance between them is 5 kilometers, and then it will get covered. It will get covered in 15 minutes. Understood? Then next. Then let's do this. A cyclist A starts down the road at a speed of 15 km per hour. Cyclist B starts at 20 minutes later from the same spot at a speed of 20 km per hour. B will overtake A after how many hours? Now, see, initially A and B are at same place. Then, cyclist A starts down a road at a speed of 15 km per hour. So, A starts going at 15 km per hour. Then a cyclist B starts 20 minutes later. 20 minutes later, cyclist B starts. Now, see the other scenario. So B is still here. This is after 20 minutes. B is still here at the starting point. A has reached where? We don't know. But this is somewhere A. Correct? Now, A is at what distance? First of all, this is important. So A goes at what speed? A starts with a speed of 15 km per hour, travels for 20 minutes. So in 20 minutes, if it goes 15 km in 1 hour, in 20 minutes, how much it will go? It will go 5 kilometers, or just calculate it. So 15 kilometer per hour is the speed. The distance I have to calculate how much has A traveled by there. So distance is equals to speed into time. Time is what? 20 minutes. 20 minutes means what? 20 by 60 hours. Hours cancel. What you got? 15 into 1 by 3. Correct? Or 5 kilometers. So this comes out to be 5 kilometers. Now, Now you see, now B will also start moving. B moves at what speed? B moves at 20 km per hour, and A continues to move at 15 km per hour. Okay, understand? Understand this, that you can make a note point that we calculate distance apart and relative speed only at the time both objects start moving, not before that. So first thing is when they both start moving. Right now A is moving, but B is still in its place. So B is not moving. So we cannot take the distance apart, relative speed, nothing here. When A reaches 5 km, now B starts moving. So now we will take this distance and now we'll take the relative speed. Okay. So now formula is same. Time is equals to distance apart divided by relative speed. Distance apart is what? What is the distance between them? Right now, when they both start moving, 5 kilometers. So this becomes 5 km upon. Relative speed is what? What is the relative speed between them? Relative speed is 20 and 15. That means they're moving in same direction. So it will be subtracted. 20 minus 15 is 5 km per hour. So time taken will be what? 5 and 5 cancel out. It will go above. So this becomes time is equals to 1 hour. Now, B will overtake A after how many hours? So what you got? It will overtake A in 1 hour. That's it. So what's the answer you got? You got 1 hour. Simple. Simply you have to calculate you have to first make sure that both the objects are moving. Once both start moving, then you calculate the distance apart and then you take the relative speed between them. Distance apart upon relative speeds gives you whatever time will be taken. Okay, that's it for this class. Next we'll see in the next part. Thank you. Hello everyone, welcome to another lecture on time, speed and distance. So we had done in the first part, we had done the introduction of it and some basic questions. Correct? Basic questions related to mainly the relative speed. Okay, so basic questions on relative speed we had seen. If they are coming in same in opposite direction, then the relative speeds used to add up. If they were going in same direction, it used to get subtracted. So that and questions related to it we had seen. Now we come to second type of questions that are asked in which distance is constant. Okay, so distance is constant. So usually they'll give you two scenarios. For example, let's say I have to reach from my home to my office and I am going at, let's say, 15 km per hour, then I reach 5 minutes late. If I go with a higher speed, let's say 20 km per hour, then I'll reach on time. Okay, then it will be asked what is the distance between my home and my office. Okay, so questions like these. So basically in these questions, distance is constant. That means there are two scenarios. So first scenario, let's say the speed is s1 into time taken is t1. This you remember, distance is equal to speed into time, correct? So this is for the first scenario. This is for the second scenario. That is speed 2 into time 2. Now this both is equals to same distance. For example, I was going from my home to my office. Now this distance d is actually constant, correct? Now in the first scenario I may be going at some speed, will reach in some t time, some t1 time. In the second scenario I am going at some speed s2 and I'll reach in some time t2, correct? Now once you understand this is constant, then usually in these questions you solve these two equations. You solve these two equations and you get to the value of time. Once you get the value of time, then you put it back in any of these equations to get the value of distance. Okay, you get the value of time from here. Speeds are usually given to you. You put the value of time here and then because all three of them are equal. So after solving these two, if you get the value of t, you put it back here, you get the distance. This is type 2. Okay, now let's see some questions. Okay, so this is the question. Let's see what it says. A teacher, a teacher driving her vehicle at 24 km per hour reaches her school 5 minutes late. Okay, so scenario 1 is what? Scenario 1 is teacher. This is the teacher, and teacher's speed is what? Teacher's speed is 24 km per hour, and at what time she is reaching? She is reaching school 5 minutes late. 5 minutes late. Now let's see scenario 2. Now here also the same teacher. Now if she had driven vehicle 25% faster, 25% faster from 24 km per hour, 25% is what? 1 by 4 added, or if you are not seeing it, simply in percentage we had seen 24 km per hour into 25% faster means 100 plus percentage whatever is greater. So 100 plus 25 by 100, this comes out to be 24 into 125 by 100, that is 5 by 4. If I cancel it by 25, so this goes one time, this goes 6 times, what you got? 30 km per hour. So now in the second scenario, she is going at the speed of 30 kilometers per hour, and when she goes by this speed, she reaches 4 minutes earlier than the scheduled time. So she reaches 4 minutes earlier. Now understand how many minutes a person is late or how many minutes a person is early is always calculated on the scheduled time. Whatever is the scheduled time, now if he reaches early, that means he take something less than the scheduled time, and if he is letting, if he is reaching late, then he is taking something more than the scheduled time. Now let's do this. So in the first scenario, now you understand the teacher is going from her home to the office, that is same distance always, so distance is constant. So distance is equals to speed 1 time 1 is equals to speed 2 time 2. Now what is speed 1? Speed 1 is 24 kilometer per hour. Now time, how we take, understand. So time, we always take the scheduled time to be t, scheduled time or correct time to be t. Now, if it is late, we will increase it, that is t plus 5, and if it is early, we will decrease it. So, t minus 4 will be the time. Understood? Now, in the first case, the speed is 24, okay, but this is in kilometer per hour, okay, anyway, then time is given to be t plus, because she is late, so this is t plus 5. This is equal to, now in this case the speed is 30 into, now she is early, so that is why t minus 4. Okay, now you must also multiply both sides by 5 by 18 to convert them into, because this is in kilometer per hour, this is in minutes. So what you can do, you can divide this by 60, so this also comes out to be in hour, and also this by 60, so this also comes out to be in hour. So this is kilometer per hour into hour, so hour will cancel out, and you will get the distance in kilometer when you will find it out eventually. Now let's solve these two first. So how you will solve this? First thing, you can cancel out 60 and 60 like this. Okay, 16 60 cancel out. Now here also, as you see, here you have 24t, there you have 30t, here you have 24 into 5 is 120 plus 24t is equals to 30t minus 30 into 4 is 120, so 120 120 becomes 240 is equals to 30t minus 2040 is 6t. How many times this will go? This will go one time, this will go 40. That means t came out to be 40 minutes. Now you can put it in any equation, any of them. Let's put it here. So because eventually distance is asked from you. So first thing was equating both of them, getting the scheduled time. So you got the time, then you put it back here. What you can get? You can get distance from here. Now distance will be equal to 24 into t plus 5. So t came out to be 40. 40 plus 5 is 45 divided by 60. This gives you the distance in kilometer. Correct? Now how many times this will go? This will go 3 times, this will go 4 times by 50, then this will go 1 time, this will go 6 times. So what you got? Distance came out to be 6 into 3, that is 80 kilometers. Understood? That means teacher's house to school distance is 18 kilometer. How far is her school? So it is 18 kilometer far. Understood the entire process? First thing, you identified that distance is constant, then you equated this s1 t1 is equals to s2 t2, and then you just put the values taking schedule time as t. Then if she is late, then you'll have to add. If she is early, then you'll have to subtract. That's it. Then you solved it, got the value of t, put it back to get the value of t. Simple. Okay, then let's do another one. Yeah, this was something that was asked in CSAT 2014. Okay, now you can pause and try. Okay, a worker reaches his factories 3 minutes late if his speed from his house to the factory is 5 kilometers per hour. Now again, you understand, this is scenario 1 and this is scenario 2. Now in the first scenario, worker reaches his factory 3 minutes late if his speed is 5 kilometers per hour. So if the speed is 5 kilometers per hour, he reaches 3 minutes late. Now you already know how you take time. Scheduled time is always taken as t. So if t is scheduled time, he reaches 3 minutes late, that is t plus 3. Simple. Then let's see the second scenario. Now if he walks at 6 kilometers per hour, he reaches the factory 7 minutes early. So now scenario 2 is what? If he walks at 6 kilometers per hour, he reaches 7 minutes early, that means t minus 7. Here. Now simple. Again, you know, from his house to his factory the distance is constant, it won't change every day. So this becomes distance is equals to speed 1 time 1 is equals to speed 2 time 2. Speed 1 is what? Speed 1 is 5 kilometer per hour. Okay, into time is what? Time is t plus 3, but this is in minutes, so we must convert it into hours. So divided by 60. This is equals to speed 2 is what? 6 kilometer per hour into now t minus 7 divided by 60, again to convert it into hour. This is equals to distance. We'll solve this to get the scheduled time first. Now 60 and 60 will cancel out. What you'll get? You'll get 5t plus 15 is equals to 6t minus 42. Now 42 will come here. So this becomes 15 plus 42, 57. 6t minus 5t becomes t. So t came out to be 57 minutes. Correct? Now you put it back here. Okay, you put it back here. Now what you will get? Distance will become equal to 5 into t plus 3. So t is 57. 57 plus 3 is 60. 60 divided by 60 kilometers. What you got? 60 and 60 will cancel out. Distance will come out to be 5 kilometers. This becomes your answer. Simple. You have to follow this. Okay, don't learn all these formulas, delta t, delta s. They have many different formulas. When the distance is constant, you do like this. You need not do any of this. Simply write the equations. This is just for your understanding. You will start your question after learning this. You will start your question directly from here. How much time will take to solve this? Hardly a few seconds. Correct? In half a minute you can do this calculation. Okay, even if you take a minute, then also it's fine. Okay, so this is how you get to answer. This is related to distance constant questions. That's it. Thank you. Hello everyone. Welcome to Legacy IAS. So we were dealing with the chapter of time, speed and distance. Now in the first one we had seen some basic questions and the introduction of it. That is mainly about relative speed. Then in the second one we had seen scenarios when there is constant distance. Now this is the third one where we will be understanding the concept of average speed. Okay, now first thing, how you find the average speed? So very simply, average speed is equals to total distance upon total time. Total distance upon total time is the value of average speed. Now if in this there are two different scenarios. If same distance is traveled at different speeds, and if different speeds are used for same time. That is, for example, what I am saying, just understand the difference. If it says that a vehicle goes 1 kilometer at a speed of v1 and it goes another 1 kilometer at speed of v2, this is first case. In this, distance traveled at different speed is same. Okay, now how you calculate this, that we'll see. Then the other scenario is, it tells you that a vehicle travels 1 hour at v1 speed and 1 hour at v2 speed. Okay, now in this scenario the average speed will be simply v1 plus v2 by 2. Okay, now just for a understanding, understand, in this scenario it won't be like this. It won't be like this. There are formulas for this also, but only works for two of them, so don't remember them. We'll use the general way. Okay, now why you can write something like this here and something not like this here. Understand, usually if I'd ask you average of anything, what you do, you add all of them and divide by the number of observations. That gives you the average. But here in case of speed, you can do it when they are traveling for the same number of hours at different speeds. Then you can simply find the average that I have found. If there are three like this, 1 hour, then you can find out like v1 plus v2 plus v3 by 3, no problems. But when you are traveling same distance at different speeds, then it will not be equal to that. It is just the sum and divided by number of observations. Why? Understand this simple difference. Now if a vehicle, let's say, goes from point A to point B, now distance is same, correct? While going also, while coming also, distance will be same. Now it goes at a speed of 20 kilometer per hour. It comes back at the speed of 40 kilometer per hour. Now understand this. This is going at 20 kilometer per hour and this is coming at 40 kilometer per hour. So from A to B, when in this entire travel, what is the most normal speed of the vehicle? So for most of the time you can feel that the vehicle is traveling at 20 kilometers per hour, correct, for most of it, because this will take much more longer. Let's say distance is 40 kilometers between them. Then this will be done in 2 hours and this will be done in 1 hour. That means the vehicle traveled 2 hours at 20 kilometers per hour and at 40 kilometers per hour only for 1 hour. That is why if you add them both, 20 plus 40, 60 divided by 2, 30 won't be the answer. Something less than 30 should be the answer. Understand this difference? Because it is traveling for a much longer time at a smaller or lesser speed. That is why it won't come directly. Understood? Now let's get to the questions. So what it says, A walks from P to Q at 3 km per hour and from Q to P at 6 km per hour. What is the average speed? Okay, so P to Q at what speed? At 3 km per hour. Then he comes back at 6 km per hour. Okay, now what is asked? What is his average speed? How you will calculate this? Simply can you add them simply? 3 plus 6, 9, 9 divided by 2, 4.5. No, it is incorrect. Why? Because it is traveling much more time at 3 km per hour, much lesser time at 6 km per hour. Okay, so how you calculate this? Average speed, basic formula remains the same, that is total distance upon total time. Now, total distance is what? Total distance, let's say I assume it to be d. The distance between P and Q is d. So now total distance will be what? D it goes and d it comes back. So total distance is 2d divided by total time. Total time is how much? Total time you can write down for the first scenario. Now you know time is equals to distance upon speed. So let's write time this way. So for the first, while going from P to Q, what is the distance? Distance is d divided by what is the speed? Speed is 3 kilometers per hour. So this is the time for going from P to Q. Now plus it has to come back also. So that time will be added. Now again the distance is d, but now the speed is 6. Correct? So this will give me the answer. So how you will do this? You will simply add it. Now this becomes 2d upon 6 as LCM. This will go 2 times 2 plus 1 3. So this becomes 3d by 6. Now d and d you can cancel out. Okay. Now 1 by 2. Now 2 divided by 1 by 2. So this will get multiplied above. That is 2 into 2 gives you 4. So what you got? 4 kilometer per hour is the speed. Understood? Just a bit lesser than what you usually feel. So 3 and 6 you might feel 4.5 should have been the answer, just little less than it. Why? Because it was traveling more at 3 km per hour. So just less than this, 4 km per hour. Then next. Yeah, this was asked in CSAT 2015. What it says, two cities A and B are 360 km apart. A car goes from A to B. A car goes from, this is A to B, distance is 360 km per hour. Now it goes at what speed? A car goes at 40 km per hour and returns at 60 km per hour. What is the average speed? So average speed is what? Average speed is always equals to total distance upon total time. Total distance is what? 360 kilometer, sorry, per hour now. 360 kilometer was the distance between them, A and B. So 360 kilometer going, 360 kilometer coming back. So this becomes 720 kilometers. Then upon time will be what? Time will be again summation of distance upon speed. This will give me total time, correct? So distance upon speed, distance upon speed. Now what is the distance here? 360 kilometer. So this becomes 360 divided by speed. Speed is what? Speed is 40. Then while coming back, distance is again 360 divided by speed is what? 60. How many times this will go? 720 divided by, now this goes 0 0, this will go 1 time 9 time, this goes 9 time plus 0 0 cancel, 1 time 6 time, so this becomes 6. What you got? 720, 9 plus 6 is 15, correct? 9 plus 6 is 15, so 720 by 15. What you get? It will go 1 time, this will go how many times? 4 times. With 60, 12 will remain, with 120 it will go 8 times. So answer came out to be average speed is equals to 48 km per hour. So answer would be this, 48. Okay, usually I can tell you one trick. What you can do, if you have to just find the answer somehow, what you can do instead of doing all this, see, the speed while going is 40, while coming back is 60. Just find the average of them, like we would have normally done. So 40 plus 60 is 100, 100 divided by 2 is 50. But you know the theory that it will be traveling at the lower speed for much longer. So this average will get decreased by something. So slightly less than this. Now, which is slightly less than this? 50 is there. 55 of course not possible. 50 is not possible. 48 is slightly less. So 48 becomes the answer. Also by simple understanding you can do in that the speed was 20 and 30 and the average was coming out to be 25. Then the answer was 24. That is one was decreased. Okay, here what you are decreasing, here you are decreasing it by 2, because similarly everything is multiplied by 2. So what you can do, if the options are far apart like this, what you can do, you can simply take the average and then just reduce it slightly. That will give you the average speed. Okay, okay, that's it for this lecture. Thank you. Okay, hello. So welcome to Legacy IAS. Now this is the fourth part related to time, speed and distance. In the initial ones, we had seen time, speed and distance, some basic concepts related to relative speed, some questions we did. Then we did some questions related to distance being constant. Then we did questions related to average speed. Now, today's topic is train problems. Train related problems. Now, see this. So basically, if there is a train, and there is a pole like this here. Now see, if let's say this train is traveling at let's say 10 meter per second or some kilometer per hour, whatever. Now you see, I ask you, in how much time will this train cross the pole? Now crossing the pole means what? In case of train, now when the first or the initial part of the train reaches here, that is when you start to count, the train is crossing a pole. Now when do you consider the train has crossed the pole? When it has completely crossed it, that is the end point of the train train crosses the pole. That means the start of the train, when it crosses the pole, let's say this is the pole. Now this is my hand, this is the start of the train. Now from here you will start, because now the train is starting to cross the pole. Now this will continue till the end of my hand. Now let's say the train ends here, so it ends here. Now I can say that the train has crossed the pole. So how much distance has it traveled? Starting from here, it goes till here, equal to the length of my hand or length of the tree. So here you can get that time taken will be equal to length of train upon speed of train. This is time taken to cross a pole or cross a pole. For now, just understand it like this way. Time taken to cross a pole will be equal to length of train divided by speed of train. This is the first kind of questions that you see. Now, let's solve this question. You understand this concept? Now, a train running at 60 kilometers per hour crosses a pole in 9 seconds. What is the length of the train? Okay, train is going at 60 kilometers per hour. Then it crosses a pole in 9 seconds. So what you can first do, you can convert this 60 kilometer per hour into meter per second. How you can do this? This will be kilometer per hour to meter per second. How is the conversion? See, the conversion is fairly simple. If you have to go from kilometer per hour, then 1 kilometer per hour is equals to 5 by 18 meter per second. And opposite will be when you have to change from meter per second to kilometer per hour. So if it is 60 kilometer per hour, it will be How much in meter per second? 60 into 5 by 18. Okay, so this you get 60 into 5 by 18 meter per second. This is the speed of the train. Now this is the time that it is taking. This is the speed of the train. Length is asked from you. So easily you can get to this. Time taken to cross the pole is 9 seconds. So write 9 here. What is the length of the train? We don't know. This is what we have to find. Speed of the train is 60 into 5 by 18. Now I can send this whole thing on the other side in multiplication. So this will become L is equals to 9 into 60 into 5 by 18. Okay, how many times this will go? 1 time, 2 times, 1 time and 30 times. 30 into 5, this comes out to be 150 meters. So answer becomes D, that is 150 meter. Understood? So if there is a pole, how much time the train will take to process? Whatever is the length of the train divided by the speed of the train. You have to be careful about the units that you are using. So if you are using kilometer per hour, then you use time also in hour. If you are using meter per second, then time also will be in seconds. Now here time was in seconds, so I converted it into meter per second. Understood? That's it. Now let's do another question. Now, this is a similar question that is asked by UPSC. A 200-meter long train is moving at 40 km per hour. In how many seconds will it cross a man standing near the railway line? Now, a pole standing or a person just standing, not moving, is the same thing, correct? In whatever time it crosses the pole, in that time only it will cross the person also. We are not considering the width of the person because it is negligible with respect to length of the entire train. So, formula and everything will still be same. Just here time taken to cross a pole or a standing person. A person that is standing is just like a pole is equals to length of train divided by speed of train. Simple, same thing. Now length of train is given to be 200 meters, is given to be 200 meters. Now 200 meters is the length of train divided by speed of train is given to be 40, but 40 is given in kilometer per hour. How can I convert it into meter per second? Into 5 by 18. So 40 into 5 by 18 meter per second. Correct? How many times this will get cancelled out? Can you see 40 into 5 is also 200 and this is also 200? Correct? 40 into 5 is 200. This is 200. You can cancel both of them. What you get, 18 will go above. So you will get 18 seconds as your answer. So your answer becomes 18 seconds. Same as before. Now, this is another type of question that they ask. In this, instead of the pole, now you have, let's say, a platform or a bridge. You have a platform or a bridge. Now this will be, let's say, of length L2 and this is your train. This is your train of length L1. Now to cross the entire platform, just like there, it had to cross the pole, correct? So the entire length of the train was the length it has to cover. Now here, apart from the length of the train, the length of the platform or bridge also has to be covered. Why? Because let's say this is a train and this is the start of the train, this is the end of the train. Now it starts moving. Now see, the start point of it has crossed the entire platform, but still the train is still on the platform. When it will cover the entire platform, when the end point also moves out of the platform, that is, it has to move distance equivalent to sum of both of them. So here time taken to cross a platform or bridge will be equal to whatever is the length. So length is L1 plus L2, that is length of the platform or bridge and length of the train divided by speed of train. Correct? So what it will be? Whatever is given in the question. Now let's see this question. A train of length 150 meters moving at 90 km per hour crosses a 200-meter bridge in what time? So L1 plus L2. Now length of the train is 150. So 150 plus L2. L2 is what? 200-meter bridge. So this is the second length. So plus 200 divided by whatever is the speed of the train. Now this is in meters. So speed also has to be in meter. So this becomes 90 into 5 by 18 meter per second. Correct? How many times this will go? 200 plus 150 is 350 meter divided by, now 18 ones are 18, 18 fives are 90, 5 fives are 25 meter per second. How many times this will go? 25 ones are, this will go one time, 10 will remain with 100, 10 plus 1 0, so 100, 100, this will go 4 times. So answer came out to be 14 seconds. B becomes your answer. Understood? Why this changed? Because now it has to cross the entire platform. Okay, now okay, now let's try this question. What it says, a 225-meter long train runs at 30 km per hour. How much time does it take to cross a man running at 3 km per hour in the same direction? Okay, now understand this. So this is the train, this is the train. Now let's say length of train is L. Now there is also one person. Now this train has to cross this person. So the length it has to cover is L only. But this person is not like the earlier person which was standing in its place. This person is also running at 3 km per hour in the same direction. So he is also going at 3 km per hour. Now speed of train is 30 km per hour. They are moving in the same direction. So whatever is the length of the train or whatever distance it has to cover will be covered by their relative speeds. Correct? Relative speeds that we had learned in the first video itself. So relative speed of both of these. Now if they are moving in the same direction, then this will be 27 km per hour. Correct? Because they are moving in same direction, so it will be subtracted. So now this relative speed becomes 27 km per hour. It will help us cover this L length of train. Now, so time taken will be what? Time taken will be equal to, of course, L is, that is length of train divided by speed of train minus speed of person, or their relative speeds directly. Okay, so let's try this question. What is the length of the train? Length is 225 meter divided by, now it is going at 30 km per hour. Now how much time does it take to cross a man running at 3 km per hour? We have already calculated this. Relative speed is 27. 30 minus 3, so this comes out to be 27, but this is in kilometer per hour. So first convert it into meter per second. So into 5 by 18 meter per second. This gives me time. Okay, now what we'll get? 27 and 18, you can clearly divide it by 9. So this gets divided twice, this gets divided thrice. Now what you got? 2 you can send above. So this becomes 450. 225 into 2 divided by 3 into 5 is 15. 450 divided by 15 seconds. That means how many times this will go? 15 ones are 15. 450 means 3 times 45 and 0. So answer will come out to be 30 seconds. B becomes your answer. Understood? All the three cases. Now you can also calculate if both trains are moving, if two persons are moving, they are moving in same direction, opposite direction. All you have to do is find the relative speed and the length it has to cover. Understood? So in the first one, pole or the standing person not moving, so simply it will be length of train divided by speed of train. In the other one, now you have something that has a bigger length, for example platform, so you add the lengths. Then in the third one, the object that the train has to cross is also moving. So if it is moving in same direction, you subtract the speed, find the relative speed. If it is moving in opposite direction, you add the speeds. Okay, that's it to find the time. That's it for this. Thank you. Hello everyone, welcome to Legacy IAS. We were dealing with time, speed and distance. Now, we had seen these in the initial lectures, that is introduction basic questions related to relative speed. Then we dealt with questions that involved fixed distance or distance being constant. So you equated S1 T1 with S1 T2, S2 T2. Then we saw questions related to average speed, then some train problems. Today we'll be seeing both problems. Now, here there are a few terms that you need to understand. First is upstream and downstream. What is upstream? What is downstream? So, upstream is when, let's say, this is a boat and this is a river. Now, when the boat is moving in this direction and the river is moving in this direction, when they are going in opposite direction, that you call as upstream. That is, the boat is going against the stream. The other one, that is downstream, in that what will happen? In that the boat is going in this direction and the river is also flowing in the same direction. That is called downstream. Now, by general intuition also you understand that when a boat is going downstream, that means the river is flowing in that direction and the boat is also going in that direction. It will be much easier for the boat to travel. Okay, it will cover distance faster. Now, the general thing is, the terms like, one term is there called speed of boat in still water. Speed of boat in still water. This you can write as SB. Now, speed of boat in still water, that is when boat is traveling in still water, like a swimming pool or somewhere where there is no upstream, no downstream, there is no flow in the water, then that is called speed of boat in still water. So this is SB. Now, speed of boat while going upstream. Now, if the boat is going upstream, whatever is the speed of boat, upstream means the river is opposing the motion. So you will have to subtract the speed of river from it. As we did in relative speeds, if this is opposing the motion of the boat. So this is speed of boat minus this is speed of river or stream or whatever is given. Basically, the medium which is flowing at what speed. Then, similarly, you will have speed while going downstream. So while going downstream, it will be speed of boat plus speed of river. That is, both will be added, speed of boat and speed of river. Why? Because they are going in the same direction or supporting each other. So these are the three terms that are used. Now, one formula that you can observe also, if you add both of them, if you add this speed upstream, this is speed upstream, this is this plus this minus this, and if you add speed downstream divided by 2, now you see I'm adding this and this, so speed of river and speed of river will cancel out, you'll get 2 times speed of boat. Now if I send 2 there, what you get this expression, which is speed of boat is equals to speed while going upstream plus speed while going downstream divided by 2. Okay, so this is speed of boat. To calculate it faster, if upstream and downstream speed is given to you, you can add them both, divide by 2 to get the speed of boat. Now let's try some questions. First question, very easy, basic. A man can row upstream at 14 km per hour and downstream at 26 km per hour. What is the speed of the stream? So upstream is what? Speed upstream is what? It The river is opposing the motion. So it will be speed of boat minus speed of river. Now, speed downstream will be what? River will be supporting the motion of the boat. So it will be speed of boat plus speed of river. Now, what is given in the question? A man can row upstream at 14 km per hour. So this is equals to 14, correct? And downstream at 26 km per hour. So this is equals to 26. Now, Forget this, you have to solve these two linear equations, and you've already learned how to solve linear equations like these. So this is equals to 14 and this is equals to 26. What you can do, you have to find the speed of the stream. Okay, so what you can do, you can subtract both of these equations. What it will become? It will, this plus will become minus, this plus will become minus, this plus will become minus. What will happen? Speed of boat minus speed of boat will cancel out. Minus speed of river minus speed of river, that is minus 2 times speed of river, is equals to 14 minus 26 is what? This is minus of 12. Correct? Minus minus again you can cancel out. Speed of river will come out to be 6 kilometer per hour. So answer becomes 6 kilometer per hour. Now this is fine. This is what you can do using equations. Now a much more intuitive way to think about is this. This is speed of boat upstream. This is speed of boat downstream. Speed of boat downstream will be much bigger than the speed of boat upstream. Now, what we had seen in that formula, speed while going upstream plus speed while going downstream, if you add them, divided by 2, you get speed of boat. So, speed of boat will be exactly in the middle. Speed upstream plus speed downstream, speed of boat will be in the middle. Now, if you, from this speed of boat, if you subtract speed of river, you get speed upstream. So this is minus speed of river. Now here, if you add speed of river to speed of boat, you get speed while going downstream. Now if you put the values, you don't even need to solve any equations. Speed while going upstream is what? 14. While coming downstream is 26. What is the average? 14 plus 26. So it is 30 plus 40. 40 divided by 2. This becomes 20. Now you look in any direction, whatever is the difference is actually speed of river. So 20 to 26, what is the difference? 6. 14 to 20, what is the difference? 6. In both cases you are getting 6, which is the speed of river. So using this diagram you can do it much faster and much more intuitively. Understood? Okay, then next. Now let's see this question. A boat takes 11 hours for traveling downstream. Okay, 11 hours for traveling downstream from point A to point B and coming back to point C midway between A and B. Okay, so this is an entire journey of the boat in which it is traveling from A to B and then it is coming back to C, where C is the middle point between A and B. Understood? So a boat takes 11 hours for traveling downstream from point A to point B and coming back to point C, which is midway between A and B. Now, if the velocity of the stream is 3 km per hour and the speed of the boat in still water is 12 km per hour, this is what? This is speed of boat, and this 3 km per hour is the speed of stream, that is speed of river. Now, what is the distance between A and B? So distance I have to calculate. Now, I assume this whole distance to be, let's say, 2d. I can assume it to be d and d by 2 also, but let's assume this whole distance is 2d. Now, or let's assume d. So this distance is d. From A to B, the distance is d. Then from B to C, C is right at the middle point. So this becomes what? This becomes d by, correct? So in total, it is traveling d and then d by 2. But this entire journey won't be at the same speed, correct? Why? Because from A to B, now if the river is flowing like this, so river's direction won't change. So from A to B it is going downstream, but from B to C it is coming upstream, so it is changing. Now total time is given to you as 11 hours. So total time is equals to 11 hours. Now this will be equal to what? This will be equal to, time is equals to distance upon speed for both the journeys. So from A to B, what is the distance? Distance is d. What is the speed? Speed is actually, because it is going downstream first, so speed will be speed of boat plus speed of river. This is speed while going downstream. So this is what? 12 plus 3, that is 15. So speed while going downstream is 15. So d divided by 15 plus. The other is going only while going upstream, it is only traveling d by 2 distance. So let's write d by 2. Now what is the speed now? It will be difference between the two, that is 12 minus 3, that is 9. Correct? This is an easy equation. Now you can finally solve for d. So this will come out to be 11. This will be equal to, now this is 15 and this is 18. 18 and 15, what will be the LCM? 18 5s are 90 and 15 6s are also 90. So this comes out to be 90. Now how many times it went? It went 6 times and this one went 5 times. So this becomes 11 is equals to 11d by 90. Correct? 11 and 11 you can cancel out. What you get? D is equals to 90 kilometers. So D becomes your final answer. Understood? Okay. Then next. This is a previous year question. Now what it says, a boat takes half time in rowing a certain distance downstream then upstream. Okay, what is the ratio of speed of the boat in still water to the speed of the current? Speed of the current means what? This means speed of river only, and speed of boat in still water, this is what? Speed of boat. That's it. Now boat takes half time in rowing a certain distance downstream. So now see, distance is same. So from A to B it is going. Now while going from A to B downstream, it is taking some time. Okay, so that is T downstream. While coming up, it is taking some time, which is T upstream. Now if distance is constant between them, that is A to B distance is same. If you are going from A to B or B to A, the distance is same. So time taken, if the distance is same, as we had done in distance constant problem, what we have done, distance is equals to speed into time. So if you see here, it will be speed while going upstream into time taken upstream is equals to speed while going downstream into time taken while going downstream. Okay, now if both of these are equal, now you see I can write that speed time while going upstream divided by time by going downstream is equals to this. So the ratio of time will be opposite of the ratio of speeds. So ratio of speeds will be opposite that of time. Now what is given in the question? It is given the boat takes half time in rowing a certain distance downstream. So that means time taken downstream ratio time taken upstream. Now this is half. So this is 1:2. So this is 1:2. Time taken downstream is of course less, time taken upstream is of course more. Now can you tell anything about the speed? Yes, the speed will be exactly opposite. Speed while going downstream ratio speed while going upstream will be 2:1. Why? Because distance is constant. So this holds. So 2:1 you got. Now what is the ratio of speed of boat in still water to the speed of the current? Now there are many ways to do this now, but the most easiest way is again drawing this. Now I assume it to be 2 km and 1 km per hour. Does not matter. Only ratio is given to me. Correct. And ratio only is asked. Now ratio only is eventually asked. So what I can do? Simply I write speed while going upstream, speed while going downstream. This is speed of both. Now according to this, this is given to be 2 and this is given to be 1. So speed of boat will be what? This is 2, this is 1. Somewhere in the middle, exactly in the middle, that is 3/2. So if this is 3/2, this is 3/2, then speed of river is what? You see the difference here or here. In both cases, you can see the difference is 0.5 kilometer per hour. So this becomes speed of the river. So now you have the speed of boat and speed of river. Let's write it as 1/2, whatever you like. So you write 1/2 or 0.5. Now what is asked? What is the ratio of speed of boat in still water? That is speed of boat to the speed of current. Speed of current is what? Speed of river. Speed of boat in still water is what? This comes out to be 3/2. So this is 3/2 divided by speed of river is what? 1/2. What will happen? 2 and 2 will cancel out. What you will get? 3:1. Anyway, you understand that 1.5 is 3 times 0.5. Correct? 0.5 into 3 is 1.5. So ratio came out to be 3:1. Answer becomes this 3:1. Understood? Simple. What you have to do, only remember this diagram and what does speed upstream and downstream mean. Right in the middle will be speed of the boat. That's it. That's it for this class. Thank you. Hello everyone. Welcome to Legacy IAS. So we are continuing with our time, speed and distance lectures. Now we have come to the next topic. This is the last topic, which is related to races. Now races, as you know, there are two kinds of races that we'll be dealing with. One is linear and one is circular. Linear races is the normal race that you see in 100 meters, 200 meters, correct? So straight line, many people go in a straight line like this. Now whoever reaches first this, that, you understand that. Now circular ones are when they are moving in a circle and they are completing laps. This you might have seen in 400 into 400-meter relays. You might have seen they go in a circle, correct? So they have to complete rounds. In marathon also, if it is not available, outside court is not available, they do it inside the court. There also they are moving in circular motion, correct? So this is circular race, this is linear race. Now our topic for today is only linear races. Now let's see. In linear races, you understand what is a linear race. 100-meter, all of them have to go. By how much distance one person wins, by how much time one person wins, this you understand. Now see this. There are two terms that are important here. One is gives a head start, or sometimes it will be written only start. Gives a start of, let's say, 10 meters, okay? And the other is wins by 20 meter. Now we'll understand both the terms. Understand this. So there is this person, okay, and let's draw one more person. This is the other person. Now both are starting at the same point and then they are trying to complete this race and go till here. This is the finish line. So this is the finish line. They're trying to go there. Now I say that this red one covers, let's say this is of 100 meters. Now the red one completes it first. Red one wins the race. Now the scenario is when red one reaches here, that is at the final point, then black will be some meters behind, correct? Black will be some meters behind when this red one reaches the end. So let's say the black one reaches here at some point here. Now whatever is this distance, this was the total length of the race. Now whatever is this distance when red has completed and black is left behind, this distance is written as, let's say this is 20 meters. Then what you will write? You will write that red won the race by 20 meters, or when red crosses the finish line, black is still 20 meters behind. When red crosses the finish line, black is still 20 meters behind. So this is wins by 20 meter, or black is still 20 meters behind when red finishes. So one term is this. Understood? When one completes, how behind is the other person. This is the first term. Now second term is gives a start of 10 meters or gives a head start of 10 meters. Now understand this. So what red says that I always win, okay, I'm a very good runner. Now black, you're not that good of a runner. So what I will do is I'll give you a head start, like you do with your nieces and nephews. So what you will say that you don't start from here. Instead you start from here. Let's say from 10 meters ahead of me. And then you start running and then I'll also start running and then we'll see who wins the race. Now by simple logic, you can understand in the time that red completes 100 meter, black completes only 20 meter less. That means black completes only 80 meters. So from here, 10 meters also, it will cover 80 meters more by the time the red reaches the finish line. So now it reaches 90 meters. Now you can say that red won by 10 meters. Understood? So this is giving a head start, okay, or giving a start. That is, some other person is being allowed to stand in front of this person and start the race from there. Now head start can depend. Here I have given a head start of 10 meters. I can, if I give a head start of 20 meters, can you see both of them will reach at the same time? If I give a head start of 30 meters, then black will start winning. Understood? So this is head start, and the other is win by this much or left behind by this much. Both terms you understand? That's it. Now we'll get to questions. Now see, this is a previous year question from 2015. What it says? It says, in a 500-meter race, B starts 45 meters ahead of A, but A wins the race while B is still 35 meters behind. You understand both the terms now? Now, so this is a 500-meter race. This is a 500-meter race. Now, what it says? B starts 45 meters ahead of A. So A is here, okay, and B is starting 45 meters 45 meters ahead of A. Correct? Now, okay, but A wins the race while B is still 35 meters behind. So now, when, see, this is the starting snapshot. Okay, I took the picture at the start. So this will look like this. Now, at the end, A will reach here, correct? At the end point. Now, according to the question, B is still B is still 35 meters behind. Correct? When A finishes, B is still 35 meters behind. Now it is asked, what is the ratio of the speed of A to B, assuming that both start at the same time. Now, this basic thing, now by now you understand that if in this case time is constant, correct, both are moving for the same amount of time, starting at the same point, ending at the same point, correct. Now, so if time is constant, then distance 1 ratio distance 2 will be equal to speed 1 ratio speed 2, because speed is equals to distance upon time, time is same, so you cancel that out. Now, that means distance traveled by A ratio distance traveled by B is equal to speed of A ratio speed of B. So this, if I find out, I can find out this. Actually, it will be exactly same. So distance traveled by A kya hoga? What will be the distance traveled by A and what will be the distance traveled by B? This only will become my speeds ratio. Now, distance traveled by A is how much? See this. Starts from here and keeps going till here. What is this total distance? This is 500 meters. Correct? Now, what is the distance covered by B? What is the distance covered by B? So it starts from here. Now it goes till here only. How much distance? So this is 500 minus 45 and minus 35. 45 and 35 is 45 plus 35 is 80. So 500 minus 80, that means 420. Understood? So 80 meters I subtracted this 45 and this 35. Correct? So 80 meters I subtracted, what I got? 420 meters. That means in the time that A travels 500 meters, B only travels 420 meters. Now this will also give me a ratio of their speeds. In the time that A travels 500 meters, B travels 420 meters. Now this is simple. Now what you get? 500 and 420. How many times this will go? 0, 0 cancel out. This will go 25 and 21. This is the ratio. Answer becomes. Understood? Simple. Okay. Then next. Now see this. In a 10-kilometer race, A, B, and C are competing. Each running at uniform speed gets the gold, silver, and bronze medals respectively. That means A won gold, B won silver, and C won bronze. C came third. If A beats B by 1 kilometer and B beats C by 1 kilometer, then how much meters does A beat C by? Now, understand this. Again, what we'll do? You understand that if time taken is same, then you can find the ratios by their speeds, correct? Or speeds ratio you can get from the distance. Now let's see the first thing. So it's a 10-kilometer race, 10-kilometer race. Now A beats B by 1 kilometer. Now that means distance traveled by A, or let me write it directly now, speed of A ratio speed of B will be what? In the time that A completes the race, A wins the race by 1 kilometer. So when A completes, this is A, when A completes 10 kilometer, B completes how much? B starts from the same point and covers only 9 kilometer, correct? Because B loses by 1 kilometer, or it says that A beats B by 1 kilometer. So B is covering 9 kilometer in that same time. Now if it is so, then the speeds ratio will be 10 ratio 9, correct? Speed of, because speed will be equal to their distances covered ratio, so this becomes 10 ratio 9. Now once you get this 10 ratio 9, now similarly you can find speed of B and C also, their ratio. So what it says, and B beats C by 1 kilometer. That means what? When B reaches, when B reaches 10 kilometers, then C is how far? C is C has traveled 9 kilometer, or is 1 kilometers behind. So now similarly you can get the ratio of speed of B and C also. That also comes out to be 10 ratio. Understood till here? Now it is asked, then how many meters does A beat C by? Now if A and C are competing, then by how many meters will A beat C by? Okay, now some people might think that because A is beating B by 1 kilometer and B is beating C by 1 kilometer, so A beats C by 2 kilometers. This is wrong. Why this is wrong? Because till here B has not completed the race. When B completes the race, then only you can say B beats C by 1 kilometer. If B has also not completed, we don't know clearly, correct? So that's why you have to go this way. So you have found both the ratios. Now you can simply find the ratio of speed of A and speed of C. How you can find the ratio? If you remember anything, it used to be like speed of A ratio speed of B ratio speed of C will be what? You just wrote the ratios like this. So 10 ratio 9, and this is B ratio C. So this is 10 ratio 9 again. Then whatever is there in the neighboring place, you write there also. Whatever is there in the neighboring place, you write here also. So what you got? You got 100 ratio 90 ratio 81. That means speed of A to speed of C will be 100 ratio 81. Now what is asked in the question? Then how many meters does A beat C by? So A beats C by how many meters? Now understand this. How many meters A will beat C by? Okay, so this is a 10-kilometer race. So I think all these options will have one more zero. So this will be 900, 1000, 1900 and 2000. Now see, so 181. That means if in the time that A travels 81 meters, C travels only, sorry, in the time that A travels 100 meters, C travels only 81 meters. Now according to the question, A will travel how many? A will travel 10 kilometers. 10 kilometers means what? 10 kilometers means what? Into 100 meters, that means 10,000 meters. Correct? So when A travels 10,000 meters, how much C will travel? You can just multiply this 100 by 1000 and 81 by 1000. So what you get here? You get here 10,000 ratio 9,000 and ratio 8100. Correct? So when A travels 10 kilometer or 10,000 meters, then C covers 8100 meters. What is the difference between them? What is the difference between them? 10,000 minus 8100, answer comes out to be 1900 meters. So answer becomes 1900 meters. That means A does not beat C by 2 kilometers, not 2000 meters, but by 1.9 kilometers. Understood the difference? So that is why answer will be what? 1900 meters. Got it? First you found out the ratio of speed of A and speed of C, and then you can just find it using multiples. Okay, so if in 100 meters it is leaving it 19 meters behind, then in 10,000 meters or in 1000 times if you do, it will be 1900 meters behind. That's it. Simple. Okay. Then let's do another question. Now see this. What it says, in a 500-meter race, E reaches the final point in 28 seconds and B reaches in 35 seconds. By how much distance does A beat B? So this is easy. How you will calculate this? This is a 500-meter race. Now it says A reaches the final point in 28 seconds. So A reaches in 28 seconds and B reaches in 35 seconds. By how much distance does A beat B? Now understand this, that when A reaches here, B is still somewhere behind. Correct? Because B still has to complete that distance. So B is still behind. Now, how behind is B? How behind is B? See. So if this is 28 and this is 35, difference is 7 seconds. That means B will have to travel still 7 more seconds to reach the end point. So 7 more seconds has to be traveled by who? By B to cover this distance. Or if I have to calculate this distance, then it will be what? It will be speed of B into 7 seconds. Understood? Speed of B into 7 seconds will give me what? This distance by which A won against B. Now, if this is so, now speed of B I have to calculate. So speed of B will be what? 500 meter. This is the distance upon time. Time is what? 35 seconds. This into 7 seconds, second cancel out. Now 7 and 35 also cancel out. One time, 5 times. This will go one time. This will go 100. So what you got? You got 100 meters. That means A beats B by 100 meters. Simple, understood? You will take speed of B because B only at its speed will cover this remaining distance in 7 seconds, not the speed of A, of course. Understood? That's it. Now, last question. Yeah. So this is what came in CST 2019. Now it says what? X, Y, Z are 3 contestants in a race of 1000 meter. Assume that all run with different uniform speeds. X gives Y a start of 40 meters and X gives Z a start of 64 meter. If Y and Z were to compete in a race of 1000 meter, how many meter starts will Y give to Z? So basically they are giving each other starts so that they reach at the same time. Now these are the different starts they are giving. Now what is given in the question, that the race is of 1000 meters. Now X, Y, Z are the 3 contestants. They all run with uniform speeds. Now X gives Y a start of 40 meters. So here is X, here is X. Y will be where? Y will be here at some distance, that is 40 meters. Correct? Now, and X gives Z a start of 64 meters. So Z will be somewhere here and this distance will be what? 64 meter. Now you can also find this distance between Y and Z. This will be 24 meter. Correct? 40 plus 24 is equals to 64. Now once you get this, now it says if Y and Z were to compete in a 1000 meter race, how many meter start should Y give to Z? Now understand this. Again, the traditional method is what? I can find out the speed ratios. So let's find out the ratio of speed of A, B and C. What it will be? It will be the ratio of their distances. So A, X covers x, y, z, x, y, and z. So x covers how much distance? X covers how much distance? X covers the entire 1000 meter. Now y covers how much distance? 40 meters less, that means 960 meters. Z covers 64 meters less, that means 936 meters. Now you can divide this by 4, all of them. So what you get? You get 250 ratio. This goes how many times? This goes 2 times. 1 will remain. With 16 it will go 4 times and 0. This goes 2 times, then 1 will remain. With 13 it will go 3 times, then 1 will remain. With 16 it will go 4 times. Correct? 2 times. With 13 it will go 3 times, 1 will remain, and with 16 it will go 4 times. Yeah, 4 into 3, 4. Yeah, so this is what you got. Now you can again divide this by, let's say you divide it by 2 again. So what you get? You get 125, and here you get 120, here you get 117. Then again you can divide it by 3. So what you get? You get here 40, and you get here 39. Now 40 and 39 is the ratio that you got between speed of y and speed of z. So speed of y ratio speed of z came out to be 40 ratio 39. If this is so, 40 ratio 39. Now, but this is for what distance? This is only for when they are not completing the race. So in this case, A is going, or y is going 960 meters, but in the question it asks when y goes 1000 meter, then what will be the start that y can give to z. So this I have to reach till 1000 meters. So 40 ratio 39 is fine. Now I want both of them to reach 1000 meters. So what I can do? I can simply multiply this with the, if I multiply 40 by 2.5, can you see 40 into 2.5 will be 100. So if I multiply both sides by 25, I can multiply it in any ratio. So 40 into 25 will come out to be 1000, and 39 into 25 will be what? Just 40 less, correct? So this will be, sorry, just 25 less, so this will be 975. So what you got? You got 1000 meter and 975 meters. So how much is the start that y should give to z? It will come out to be 25 meters. So answer becomes 25 meters. Understood? Now let's see a much faster way of doing this. This is fine. Okay, now see this. See this. Simple unitary method will follow. So this is x, this is y, this is z, this is 40, this was 24, and this was the end of the race. This whole thing was 500, sorry, was 1000 meters. Correct? Now see y and z, what is the difference between them right now? If you see, the difference between them is of 24 meters. Y and z difference is 24 meters. Now if you consider this as a race, this is the starting point, correct? And it is going how many meters? 40 meters less. That means this is a race of 960 meters. So if this is a 960 meter race, then y is giving z a start of 24 meters. So I write, if it is a 960 meter race, y gives z a start of 24 meters. If it is 960 meter race, y gives z a start of 24 meters. But according to the question, so in 960 meters, head start given is 24 meters. Now the question asks, in 1000 meters how much head start he will give. So this will be 24 divided by 96 into 1000. Simple unitary method. How many times this will go? One time, four time, one time, and this will go two. Sorry, this is 9, 60, 0, 0 cancel out. So this comes out to 25 meters. So 24 by 960, 0, 0 you cancel out. So this becomes 1, and then 24 goes 4 times. 4 goes, 4 takes 125 times. So what you got? 25 meters. This is a much simpler way of thinking the same thing, that instead of finding their ratio of their speed, this that, you start from here and think, in 960-meter race, y gives z a start of 24 meters. Then in 1000-meter race, how much start should it give? 24 by 96 into 1000. Understood? And then you can find out easily, it will come out to be 25 meters. Okay, that's it for the linear races. In the next part you'll see circular races. Thank you. Hello everyone, welcome to Legacy IAS. So we will be continuing with our topic of time, speed and distance. This is the last part of it, where we'll be dealing with circular races. Okay, this is the most advanced this topic gets to. Now see, in circular races you see two kinds of questions that are asked. First is, they'll ask you, let's say there are two people, they start racing at the same time. Let's say from here both A and B start. Now they'll ask you, A is going at some speed and B is going at some other speed. So their speeds are different. Let's say B is going much faster. So B will be ahead moving like this, and A will be somewhere behind like this. Correct? And then they'll ask you when they will meet next. So they were together at the start, when they'll meet next. So there simply you need to find the LCM. Times are given to you, that this much time it takes for A to complete one round, for B to complete one round, this much time it takes. Simply you need to find the LCM that we usually did in the HCL LCM chapter of number system. So that is fine. Now another type of question that is asked is this, that is how many times they would cross or meet in a duration. For this there is an entire process that we'll be learning. That means instead of asking you when they will meet next or giving you timings, they will just tell you speeds of A and B, and then based on that speed they will ask you in the next 1.5 hours or in the next 2 hours how many times they will cross each other or how many times they'll meet. Okay, so this is what is usually asked. Now understand one thing. Now A and B can be, let's say they start from here, both of them are here. Now they can be moving in the same direction at different speeds. Let's say A is moving in this direction and B is also moving in the same direction. Now when can they meet next? If they have different velocities, let's call that A completes 2 rounds per minute and B completes, let's say, 4 rounds per minute. Just intuition you have to develop here. So A completes 2 rounds in 1 minute and B completes 4 rounds in 1 minute. Now when they will cross each other, understand that B is moving ahead, so B will keep on moving ahead, keep moving ahead of A, and A will be following B. They will only cross when B completes one more round than A. Okay, that is the only scenario they can meet. Otherwise, if B is going in this direction and A is also going in this direction, then this gap will never be covered. This gap can only be covered, let's say this is B, this is A. Now A is moving slowly like this. So A is moving, this is A is moving slowly like this. Okay, and this is B. Now they have to meet. Now B is faster, so B will keep moving with a much more distance between A and B. Eventually they can meet when A has moved just slightly and B catches one more round and catches A somewhere here. So A has moved only this much, and in that time B has moved this whole circle and then came to meet A. That is when the difference between them covers 1 round. Okay, so as you know, if they are going both in same direction, if they are going in same direction, the speeds are subtracted. So speeds will be subtracted, and with this speed they will have to cover 1 round to cross one time. Correct? Now if they are moving in opposite direction, that is A is here and B is here at the start. Now A is moving in this direction and B is moving in this direction. Okay, now what will happen? This is A, let's say. Now A is moving at some speed and B is moving at some other speed. Now they can meet. How they can meet? Now can you see that they need not go one full round? Let's say B is traveling faster, so B travels this much. Not completed one round yet, and A moves this much, and they can meet. Can you see? Both of them have not completed one round and they meet. Here B had completed one round and then came back and then met A. Correct? So here they can, even if now if you see, B has traveled this much and A has traveled this much, so together they are completing one round and then they meet. So this becomes if their speeds of A and B are whatever, then this will be, now because they are moving in opposite direction, their speeds will be added, and with this S1 plus S2 they will try to cover one round. When one round gets completed, they'll meet. Understood? If they are moving in same direction, then difference of their speed must become equal to one round, and here if they are moving in the opposite direction, the sum of the speeds should be able to cover one round. Those will give us the timings when they'll meet. Okay, understood? Now let's get to the questions. Yeah, all these are PYQs only. So this was asked in CSE 2022. Now what it says? It says X and Y run a 3-kilometer race along a circular course of length 300 meters. Okay, now what is the length of the total race? Total length of the race is 3 kilometers or 3000 meters. Now this is the total race. Now the course length is only 300 meters. Course length is only 300 meters. That means to complete this entire race, they have to cover 10 rounds of that same track. For example, you go to a garden and you have, let's say, an aim of I'll cover 4 kilometers, I'll walk for 4 kilometers today. Now the garden won't be a 4-kilometer circumference. This won't be 4 kilometers. Let's say this garden is only of 400 meters. Then what you will do? You will cover 10 rounds of this garden to cover 4000 meters or 4 kilometers. Similarly, they are doing it here as well. So there are 3000 meters they have to cover, 3-kilometer race is there, 300 meters is the length of this entire track. So therefore they'll cover 10 rounds. Now next, their speeds are in the ratio 3:2. If they start together in the same direction, how many times would the first one pass the other? So their speeds are given. Speed of A and speed of B is given as 3:2 X and Y. So speed of X and speed of Y is given as 3:2. Now how many times would they meet? Would the first one pass the other? That is, they meet. The start of is not counted as passing. At the start, whatever is there, that is not counted as passing. Now these are their speeds. Now speeds are in ratio 3:2. So I can assume it to be anything. I can assume it to be 3 km per hour and 2 km per hour, not a problem. Or 3 km per second and 2 km per second, does not matter. So I would usually in this chapter, because we are covering a track that is circular, we usually think in terms of this will cover 3 rounds in 1 minute, in 1 minute, and this will cover 2 rounds in 1 minute. This you understand? This means that the speed of x is 3 rounds per minute and the speed of y is 2 rounds per minute. Now if you take their ratio, it will be 3:2. Fine. The ratio is 3:2. So what I assume that that they cover that when this x cover 3 rounds, y covers only 2 rounds and then they meet. Correct? Now whatever is the difference here, now I need to, when this covers, when this is x, when x covers 3 rounds, so 1 2 3, now x is here, in the same time y will cover 2 rounds, so y will go like 1 and 2, so they will meet here. Correct? So that is the time when they meet. So after x covers 3 rounds, they meet once. That means after x covers 3 rounds, they cross. After x covers 3 rounds, they cross. Then the question is, how many times they will cross in the entire race? Now entire race means what? Now if they both are running for 3 kilometers, that means they will go for 10 rounds. Now if one of them reaches, then that is the end point, that you won't call as crossing. So what I want x2, because x is faster, I want x to cover 10 rounds, and in that time I'll see how many rounds y covers. Correct? So when x covers 3 rounds, y covers 2 rounds. When x covers 10 rounds, how many rounds y will cover? So y will cover 2/3 into 10. Correct? Because their ratio has to be 3:2. So x ratio y has to be 3:2. Now if x is covering 10, then y is asked. So it will be what? This question mark will be equal to 10 into 2/3. That's it. So 2/3 into 10. So this came out to be 10 rounds and this came out to be 20/3, that is 6.66 rounds. Now here the difference was of 1 round, so I said they will meet one time. Now here the difference is approximately of 3.33 rounds and the race is completed. Why? Because one of them has completed 10 rounds. So if you got 3.33 rounds, that means how many times they meet? You just need to worry about the whole number here, that is 3. That means they will meet how many times? They will meet 3 times. That's it. First you found out the ratio, then you understood this, the ratio is 3:2, then you assume that this was completion of 3 rounds, this was completion of 2 rounds. Now one of them has to complete 10 rounds for the race to get completed, so you make the faster one complete 10 rounds. In that time you see how many rounds has y completed, whatever is the difference, that will give you how many times they can meet. Now of course it has to be in whole numbers, so you pick the whole number, that becomes your answer. Simple. Then next, now in the first one we were taking the difference, as we got 10 here and 6.66 here, then we took the difference and got 3.33. Why we took the difference? Because they were going in same direction. Now see this question, in this they will be going in opposite direction, so we'll have to take the sum of them. Okay, so let's see this. What it says, A and B walk around a circular track. They start at 8 a.m. from the same point in the opposite directions. Okay, so let's say A moves in, this is the starting point, A moves in this direction and B moves in this direction, opposite directions. Okay, A and B walk at a speed of 2 rounds per hour and 3 rounds per hour. So A is walking at 2 rounds per hour and B is walking at 3 rounds per hour. Now how many times shall they cross each other after 8 a.m. and before 9:30? Now they are moving in opposite direction. Now some time duration is given to you, that is the time duration is 1.5 hours. How many times they'll meet? Now see this. Together they have to complete one circle, correct? So here the speeds will be added. So S1 plus S2, you get 5 rounds per hour. This means what? Together, that is, if I add both of their whatever work both of them do, if I add them, so together they cover 5 rounds in 1 hour. Together they cover 5 rounds in 1 hour. A covered 2 rounds in 1 hour, B covered 3 rounds in 1 hour. Together they cover 5 rounds in 1 hour. Now they cover 5 rounds in 1 hour. Now what is asked? In 1.5 hour, because from 8 to 9:30, so in 1 hour they complete 5 rounds together. In 1.5 hours, how many rounds they'll complete? So they'll complete 5 into, now in 1 hour they complete 5 rounds. So in 1.5 hours they will complete how many? 1.5 into 5 rounds, that is 7.5 rounds, correct? Again you will take this whole number, this is the number of times they will meet, so answer becomes 7. That's it. Understood? First, in the first case we had to find the difference and then see what is the difference between them in terms of round. That became our answer. In the second one we have to take sum of speeds because they are moving in opposite direction, and then we calculated in 1 hour they will complete how many rounds, and in 1.5 hour they will complete how many rounds. That's it. Then last is this. Last is the other type of question that we saw. 3 men start together to travel the same way around a circular track of 11 kilometers. Okay. Then their speeds are 4, 5.5 and 8 km per hour respectively. When will they meet at the starting point for the first? When they will meet at the starting point for the first time? This is very easy. How? Because you know how much time each of them takes. Then simply you have to take the LCM, like we have done questions in number system where it involved 3 different color lights and they used to light up at different times, red, yellow and green. Then it was asked when they will light up together, like that questions. So what you were doing there, you were just finding the LCM. Same thing you will do here also. Now you take the timings T1, T2 and T3 and find their LCM. That's it. That is the time when they will meet for the first time again at the start. So simply find the LCM. Now LCM of what? Time 1 is what? 11 km at 4 km per hour. So 11 by 4, because time is equals to distance by speed. So distance is 11 km, speed is 4. Then next is distance 11, speed is 5.5. Next is 11 and speed is 8. Okay. Now solve this. LCM of this is 11 by 4. This is fine. 5.5 by 11 is actually 2. Then 11 by 8, it will remain 11 by 8. This can be written as 2 by 1. Now how do you find LCM of fractions? That you must know. So it will be what? It will be, in the LCM you will have something bigger. So this has to be HCF of whatever is below, that is 4, 1, 8 and LCM of whatever is above. So what you get? 11, 2 and 11. What is the LCM? LCM is 22 and 4, 1 and 8. What is the HCF? HCF is 1. So what answer you got? You got after 22 hours they will meet at the same point again. Understood? 2 types of questions. First was related to time when they will meet. Next, for that you simply find the LCM. The other was when they are going in same direction on a circular track and when they are going in opposite direction. When they are going in same direction, you find the difference between the speeds, and difference between the rounds give you the answer. Here the sum of whatever rounds they cover in 1 hour or whatever time, that gives you the answer. That's it for the circular races. Thank you.